Hey guys, so we're going to start off with our first set of notes today, and it's going to be just about your basic science processes and science experiment information. I would imagine most of you guys have been doing this since probably even before middle school, but I do just want to make sure we go through it all. There's not going to be a test over this particular material, but you will have a lab activity coming up where you're going to practice with some of these terms, making sure you understand them. And you're also going to have your first lab quiz. And I'm going to explain a little bit more about that at the end, but this is something you may not have done before in a science class, and it's something that I definitely want to expose you to. So typically when we have a lab or labs that are kind of coordinating around the same topic, we'll have a lab quiz for the unit. And it's just to make sure that you're understanding, what you did in the lab. And so a lot of the terms that are in this particular lesson, they're actually going to be popping up on lab quizzes in the future. So I just want to make sure you have a good background. And if you know it, great. If you don't know it, we definitely need to understand it. So first off, hopefully you know that science is a process. It's not just a subject that you study in school. It's something that you can do all the time. Anybody can do it. It occurs in our daily lives. It doesn't always have to be in a lab. It doesn't always have to involve a long procedure because it literally just begins with someone having a question. And it does need to be a question that you can answer. There's some questions that we would not consider testable. And so a good testable question would usually include the independent variable and the dependent variable. And a lot of times, like on your work and things like that, it'll maybe be abbreviated IV and DV, and that's what those stand for. But let me give you an example of how you could do, science in your everyday life. Something as simple as when you're testing out products. Maybe you notice that your deodorant isn't working like it used to, and sometimes our body chemistry changes, and so maybe you decide to try out a new deodorant, or maybe you get a few different kinds when you go to the store. And you test out the deodorants to see which ones work the best. Something as simple as which deodorant is going to work the best is an example of a process of science. And so as you go through that method of testing them and kind of analyzing the data to see which ones are working the best, you may come to a conclusion. All of those are part of that scientific process. Now, an example of something that would not be testable would be something like which color Skittle tastes the best. When it's something like that, you could do a survey, but are you ever really going to be able to conclude which Skittle tastes the best? And the answer to that is really no, because that's going to be based on opinion. So it needs to be something that you can actually test and kind of support or not support with that test. And so when you have your testable question, the independent variable represents what you are actually testing. So what are you, as the experimenter, as the scientist, actually manipulating or changing? Something that you need to understand is that you actually have control over the independent variable. So it's what are you changing? Okay, so in the case of the deodorant, you were testing out different types or different brands of deodorant. You were physically purchasing them. You were physically putting the deodorants on. You were manipulating that variable. Now, the dependent variable is just simply what happens, what responds to that independent variable. So in the case of the deodorant, it's how well is it working? How well is it controlling the smell, or how well is it controlling the perspiration? And so you don't really have control over that. You can't determine how much you do or do not stink, and you can't really determine how much you do or do not sweat. In the case of the deodorant. So that just simply is your responding variable. It changes in response. So another example is I always go back, and if you've had me before, you've heard this, but I always go back to my 7th grade science fair experiment. It was not award winning, I promise you that. But we tested out the question, how do different salt concentrations affect the growth of plants? And so what we did is we used different solutions with different concentrations of salt. That would be what we are physically manipulating or changing. So the amount of salt was our independent variable. And then the plant and how it grew was the dependent variable. I can't make the plant grow, but I can adjust the amount of salt in my solution. So How do different salt concentrations affect the growth of plants? Independent is the amount of salt. Dependent is the growth of the plant. So this is something that your lab quiz that you're going to be taking is going to be specifically over the activity that you do, but there will be terms like independent and dependent variable that you need to know for quiz purposes. All right, so next up is once you form that testable question, you're going to propose an answer to that question. So maybe you think that Degree is the best deodorant, or maybe you think that the Dove brand is the best deodorant. So whatever you think, your proposed answer, that is your hypotheses. Now, if you're struggling, a lot of times you can use the if-then format. If I use Degree, then I will smell better, or something like that. That may be kind of silly, but if I use a higher concentration of salt, then the plant growth will be the least, something like that. You can also keep it very, very simple. You can just simply say the plant will grow best in lower salt concentrations, or the Degree deodorant will prevent perspiration the best, something along those lines. One thing that I often see students doing, and you do not need to do, is do not explain why. Okay, you just simply answer the question. So if you were testing out different stain removers, Tide Pen will remove the stain the best. Something like that. It doesn't have to, you don't have to explain why you think Tide is better, or why Degree is better, or why salt concentrations. Do not explain the why. Just simply write a complete statement. Now, one thing that I'll be looking for, and one thing that you need to understand, is that a good hypothesis should contain in some way both the independent and the dependent variable. You need to represent both of those. It doesn't matter the order, which one comes first or which one comes second, because you can flip them, but just make sure that both variables are represented in your hypothesis. Once again, they must be testable. So if it's not testable, it's not a good question, not a good test, not a good hypothesis. Now, something else you're going to encounter, and we won't see this again for a while, but a null hypothesis. And so normally when you're doing a test, you're trying to see how does the independent variable affect the dependent variable. And so in this case, when you're doing a null hypothesis, it simply says there is no effect. Okay, there is no relationship. So the brand of deodorant will have no effect on perspiration. The salt concentration will have no effect on the plant growth. And just like any other hypothesis, you're either going to accept it or reject it. If you accept a null hypothesis, then you're saying there doesn't really appear to be a relationship. If you reject a null hypothesis, you're just simply saying that there is some form of relationship. So it's just another type of hypothesis. You will see it a lot in statistics. So like I said, it's not something you're going to see all of the time, but when you do see that term pop up, just know it's simply stating that there is no relationship between the two variables. All right, now you need to understand kind of the hierarchy of science. So when you're doing an experiment, you're going to form a hypothesis. You are not going to prove anything with one experiment, okay? You are either going to support that hypothesis or you are going to reject that hypothesis. And that will probably lead you to more tests. Now, after something has been tested over and over and over again and shown to be true, and after others have tested and shown that connection is always there, that same relationship is existing, experiment after experiment after experiment, at that point, that hypothesis may become a theory. Now, a lot of times people misuse this term. It's one of my pet peeves when they dismiss something as just a theory. If that's the case, they don't understand what a scientific theory is, because in order to become a theory, it must be well established, it must be highly reliable, it must be widely supported, and that doesn't just mean by common everyday people. It must be widely supported in the scientific community, okay? Now, as we know, science can always change. So if new evidence arises, the theory could be disproven, it could be modified, or it could be further supported. But in order to reach that theory status, it does have to be very, very, very validated, okay? It's hard to ever use the word prove in science, but it's not a weak idea. Hypothesis, low-level science, okay? Theory, very well established. Now, the big granddaddy of science would be your laws, and laws are essentially, they take a body of evidence and observations, and they're essentially universally understood. They're really, at the time that a law is made, there are no exceptions to the rule. Like, for instance, the law of gravity. It doesn't matter how many times you hold that pencil up and you let go, it's going to hit the ground, okay? It doesn't matter why, it just matters that it does. And so scientific laws, essentially, they're very concrete, no exceptions, and they show to be true over and over again. All right, a controlled experiment. So we're going to go back to that independent and dependent variable again. And if you are wanting to do a good test, which obviously in science we always want it to be a test that is testing what we think we are testing, it needs to be a controlled experiment. And a controlled experiment is one in which all other factors remain constant, okay? The only one that stays, that actually gets changed, was that independent variable that you were manipulating. So if I want to test different salt concentrations and how they affect the growth of plants, the only thing that should be different in my test is the salt concentration, okay? So you should only ever test one independent variable at a time, because if you don't do that, you have no idea what led to the results. So I'll give you an example. If I'm going to do the plant experiment, I cannot use an ivy plant in my living room, a vase of roses in my bedroom, and a bush out in my front yard, okay? Because obviously they are clearly different plants under different conditions. They need to be in the same room, they need to receive the same amount of light, they need to be the same type of plant, same pot, same soil, same amount of solution. The only thing that should vary should be the actual salt concentration. Now, something else you need to be aware of is that in most experiments, there are some where it may not apply, but in most experiments you need what's called a control or a control group. And this is one where you don't actually apply the independent variable to it, okay? So if we went back to the deodorant, if we were testing out different deodorants, you're going to need a test where you wear no deodorant. Because you may be one of those lucky few where maybe your sweat glands aren't overactive, and you may not really sweat that bad or smell that bad with no deodorant. So if that's the case, your results may not be because of deodorant. If we're talking about the plants, I can't have a group that gets 10%, a group that gets 20%, and a group that gets 30%. If they all die, I cannot conclude that salt kills plants, because I do not have a control group, okay? So in my salt experiment, I'm going to have a plant that gets no salt. Now, it still has to get the water. There just can't be a salt concentration in it, because that way, if that plant survives, but then my 10, 20, and 30% don't do well, then I can say that there's a negative effect of salt on the plants. But if all 4 of my plants either don't grow or they grow the same, then I know it has nothing to do with the salt, okay? So I have to have one where the independent variable is not applied, so that way I have a comparison. All right, when you're collecting data, or data, however you want to say it, tomato, tomato, it's typically better to collect quantitative data. I don't know if you've ever heard these words before. I hope you have. But really there's 2 main types of data. There's quantitative and there's qualitative. If you don't know what they are, you might want to jot something down on your paper here. But quantitative is numerical data. It's actual measurements. The other type, qualitative, is more of a descriptive type of data. Now, the reason quantitative is better is because qualitative can be different for different people. So if I say, wow, that's really heavy, Well, how much mass am I talking about? Okay, because what's heavy to me may not be heavy to another person. Okay, and so quantitative, if I say that weighs 100 pounds, or I guess for science we should say 100 kilograms or whatever it may be, then that's going to be the same for everybody. So heavy is subjective, whereas quantitative, an actual measurement or value, it's going to be the same for everyone. Your collection should be consistent, how you go about collecting your data, timing, things like that. If you're using a survey, you're doing, surveying people about deodorant use or something like that, it may be silly, but you should use a very large sample size. You can't just survey 1 or 2 people and have any kind of conclusion. And you should never change your data. This is really tempting. There's a couple of labs that you're going to do this year, and sometimes they just don't work. And that's just the nature of science. That's the nature of science in a high school setting where the teacher can make mistakes, the students can make mistakes. But you should never, ever, ever change your data, okay? I've seen students do it, or I've seen students want to do it. Oh, I think we did this. Maybe if we just change this number. Well, that's not correct, okay? So whatever you get, you go with, and that right there is why we experiment multiple times to really form any type of conclusion. All right, graphing. One of the things you're going to do in your little lab activity is you're going to be expected to graph 4 different sets of data. And so this is something that, as your science teacher, I am definitely very picky about. A good graph, there are certain elements that should always be present if it is a good graph, okay? Otherwise, it's just going to be kind of a waste of information. And so at any point in this class, anytime you ever do a graph, this is kind of the same list that I will be looking for when it comes to grading your graph or analyzing your graph. So number 1, there should always be an appropriate title. And in science, we're definitely moving away from the cutesy titles that you may have done back in lower grades. It's essentially the independent and the dependent variable. So sometimes you'll just simply say the independent variable versus the dependent variable, or the effect of blank on blank, okay? But a good title should always include both. Now, typically, that independent variable is on the x-axis, and that dependent variable is on the y-axis. And so whatever your labels are, because this is another absolute must, okay, whatever your labels are, if you kind of take those, you can put them together to form your title, okay? So in the case of salt concentrations and its effect on the growth of plants, if I were to graph my data, I would want to put the different salt concentrations on the x-axis, and I would want to put the growth of the plants on my y-axis. Now, something else that's important there is units, okay? If I'm measuring in centimeters, that needs to be reflected with it, okay? If you put something like time or length or mass, you must always have a unit with it. This is something that students often struggle with, even in the higher grades, and that's just making sure that you have regular intervals, that you count by, the same increments, count by 2s, count by 5s. I've seen where students want to take the numbers in the data table and put them on an axis. And unless they are by 5s or by 10s, you really can't do that. I mean, I've seen numbers, things like 1972, 1975, 1988, 1995, and those, I've seen students just take those numbers and put them along the x-axis. And that is a big no-no, because those intervals represent a relationship, and so your graph will be skewed if you don't have even spaces or even increments. All right, if it's a line graph, you want to connect the dots, okay? You really don't want to connect to 0 unless there's actually a 0, 0 data point. And if you're extrapolating, we'll do this later on in the year, that means you're kind of going beyond the actual graph of data. You want to use a dotted line, because that, that implies that it is kind of a guess or a prediction. And then you should always, if you need to, have a key. So all of these are very important elements, and you want to be sure that you have them. All right, line bar or line versus bar graph. So one of the things you're going to have to do on your lab activity is determine what type of graph should I use. And I'm going to tell you right now that you're going to have 2 line graphs and you're going to have 2 bar graphs, okay? Now, 2 of your graphs are going to be multiple, okay? So you're going to have 1 single line graph and 1 multiple line graph, like 3 lines on the same piece of graph paper. And then you're going to have 1 just single bar, and then you're going to have 1 multi-bar, okay? So 4 graphs total. 2 are going to be line, 2 are going to be bar. One of the lines has multiple lines, and one of the bar graphs has multiple bars, okay? And when we actually get to the activity, Miss Petty can help you and kind of explain which ones are which, but you need to practice being able to figure out what kind of graph should I use. Okay, that's going to be part of your assessment, is knowing what kind of graph should be used for a particular set of data. So the key to a line graph is that it's continuous, and it typically shows change over time. Okay, so as you move along, that relationship is continuing. You're usually going to have something like slope, or you're going to have some kind of relationship. Now, bar graphs are typically used when there's independent categories. So like if I was doing different colors of M&Ms and how many come in the package, those are each independent colors. They're not going to be a continuous over time relationship. If I'm comparing people groups, individual people groups, then that would be a bar graph type of situation. So if it shows change over time, line graph. If it doesn't, if you have individual categories that don't really affect each other, then you're going to have a bar graph. All right, once you get the results of your experiment, you're going to form a conclusion. Once again, you're not really proving anything. Essentially, you're going to support or not support your hypothesis. Once again, be clear and concise. There's no reason to be wordy here. You do not want to generalize. If I did my experiment on tomato plants, I can't make conclusions about salt on all plants. I can only say that salt affected tomato plants in this way. And of course, we won't have time to do this in our classes, but we know that in science you should always repeat to ensure that you're getting consistent results. All right, last but not least, peer review. In science is social. A lot of times we think about, scientists being kind of introverted people who don't like to share their findings, and there are some that are like that, but it's very important that scientists share their discoveries and their conclusions. That way everybody has access to them. Everybody can build off the work of others. And so in order to kind of put your work out there, it must be peer reviewed. And what that means is people in that field are going to recreate those tests. They're going to analyze the science behind it, and they're going to make sure that it's valid, okay? Peer review ensures validity. If I were just to write, anybody can write anything and put it on the internet. So in order to be actually published, like in a scientific journal, it's got to be peer reviewed, and that means it's been kind of checked over. This is going to be part of the essay that you're going to do, and one of the sections is looking at peer-reviewed work versus non-peer-reviewed. And essentially, peer-reviewed means it's validated. It means it's tested by others to ensure that it is a good test, okay, and that the results do have some truth behind them. And if not, it's just simply going to be the conclusion of one person. And it could be based on opinion. It's not going to be based on good science. And that is the end of experimental design. Now, I know this video is getting kind of lengthy. I don't like that, but while I have you here, I want to go ahead and talk about the first essay. Okay, you may hear that word and think, oh my gosh. I feel the same way about essays. As your teacher, I am not a fan, okay? But I want to explain to you that these TC essays, I know that I'm the teacher of record, but I promise you they are not coming from me, okay? I do not teach dual credit biology on the TC campus, and so I'm still expected to kind of coordinate with the teacher that does. And so this is how he kind of keeps track of the SLOs. On your syllabus, it's essentially what you're supposed to learn in the course. And we have to have data that shows that you guys learn that material. And the teacher on campus here uses these essays. Now what I do, or what I did when I was in the classroom, is I kind of put my own spin on them. Okay, so this right here is TC essay number 1. You should be getting a paper that has this on it. And when you take your lab quiz over the activity that you're going to be doing for the next couple of days, on that lab quiz, you're going to have to write this essay. Okay, it'll be handwritten. You can't copy and paste, so just kind of be aware of that. But 20 points of your lab grade, your lab quiz grade, is coming from this essay. Okay, so there's kind of a couple of different parts, and I've broken it down for you. So you're going to distinguish the difference between how science and the scientific method are used to answer questions, and how other ways of knowing, like religion and philosophy, answer questions. Okay. The next part is contrast scientific peer review with those that are not scientific. Okay, so what I've done down here is I've broken down the point values. So when Miss Petty and I grade your essays, this is what we're going to be looking for. Okay, now I'm going to tell you right now, do not fill up your essay with fluff. Okay, this is not a literature essay. I do not need an opening. I do not need a closing. I do not need you to summarize the same thing 5 times. Okay, it is not about length. It is about content. Someone can write 3 sentences, probably a little bit more on this one, but someone could write a short paragraph and get all 20 points. Someone could write 3 pages and maybe only get half. Okay, it's about quality over quantity. So please do not fill up the paper with extra words. I don't like to grade these essays, and so the clearer they are and the more to the point they are, the better I like it. Okay, now it is an essay. You do need to write in complete sentences, preferably always capital letters, grammar, commas, periods, things of that nature. But I am grading for scientific points. Okay, I'm grading for discrete, you got it right or you did not. Okay, so you've got 20 points available. There are 10 things that I am looking for in this essay. Okay, so the first part, how is science used to answer questions? I'm looking for 4 valid points. Now, what do I mean by valid points? Let me give you an example. Hopefully, after doing the lesson that we just did, you know that science answers questions by doing tests or experiments. Okay? Just by you simply saying something like that, science answers questions by testing or experimenting to answer questions, that right there would be 1 valid point. So that right there would be worth 2 points. Okay? Now, there are going to be some articles that are going to be posted on Google Classroom. Miss Petty's going to post those for you. You don't have to read them. I mean, but I would encourage you to kind of go through and maybe use those if you're struggling. Okay, but that's one example of how science answers questions. Science is not subjective. It could be the same. Science should be repeated. All of those things are examples. Obviously more than just 2 words at a time. They should be in complete sentences and complete thoughts. But those are examples of what I mean by valid points. All right, so the next part, how does religion or philosophy, how do they answer questions? Once again, 4 valid points. A lot of these could be, contrasted. So where science is testable, then religion is blank, okay? Honestly, the first thing that pops in my head when it comes to religion is the concept of you have to have faith, okay? Or it depends on your beliefs. Now, to me, those are kind of the same thing. So you do have to have 4 different valid points. Like testable and experimenting, same thing. Belief system and having faith, those are kind of the same thing. But those right there would be a valid point, okay? So just by saying that science tests in order to answer questions and religion is based on faith to answer questions, that right there would have earned you 1 point here, 1 point here, for a total of 4 points, okay? And then the last part is comparing and contrasting those peer review. And if you go back to this slide and you listen to what I said about peer review, that should help you answer that question, okay? So if you're reading a non-scientific journal, anybody could have written those things. They could be opinion papers. They're typically not backed up with factual information and tests, whereas the peer review incorporates that review of those in your field. Okay, so what you're going to do, this paper right here is just for planning. Okay, on your own, over the next 2 days in class, you're going to be working on the lab activity. You could also use that time to work on your essay. But you will write it without any notes or anything like that on the actual quiz day. Okay, so be prepared for that. So what I would recommend is kind of creating an outline. Do not try to remember a whole paper. So if you go and you type this into AI and it gives you this long paper, that'll probably be harder for you, honestly. Okay, you need to outline, you need to pick out your valid points, and then be able to actually compose the essay the day of the quiz. Okay, but it's really, really hard to remember whole paragraphs. So just be familiar with the 4 points for each science versus religion, and then be sure you know what scientific peer review is, and you should be able to compose your essay. And then when I'm grading it, I grade on a check system. You need 10 checks to get your 20 points, okay? Now, 2 of your checks have got to come from this topic, and then 4 checks there, 4 checks there. So if you give me extra here, that's great, but I'm only going to give you a max of 4 checks for science. I would encourage you to write a few extra just in case one of them's wrong, okay? I don't count off for wrong answers, but I can't give you credit for wrong answers. All right, so I know this was long, but I wanted to explain, especially with this being the first essay, exactly how it's going to work. Please feel free to contact me if you have questions. Please feel free to talk to Miss Petty if you have questions. And I'll check in with you, and I'll check in with Miss Petty to see how it's going. But you will be having a quiz over the lab activity as well as this essay coming up in a few class periods. All right, I hope you guys have a wonderful day, and I will hopefully be talking to you at least through videos or maybe even seeing you soon. Y'all have a good one.